Okay, guys, I wanted to first go over the little exit slip quiz from yesterday. That was only 4 points. I wanted to incent you to do your best work, but it is a relatively newer skill, so we weren't making it for lots of points. That said, we did have our notes available to reference, and we had gone over a number of these problems using the same type of table format. So it should have been something you could have done reasonably well on. I did have most people who got at least 75% correct. Some of you got them all correct, and I just want to make sure we're all very clear about how it is that we write our parallel and perpendicular lines. So you were asked to consider each original line and then write an equation of a line parallel to it, knowing that for parallel lines, slopes are the same, but we have different y-intercepts, different b values, right? Remembering that we're writing these equations using y equals mx plus b, the slope-intercept format, and understanding that b would be the y-intercept, okay? So y-intercept, okay? M is the slope. All right. So that being said, we needed to write an equation of a line parallel to the original, and then we needed to write an equation of a line perpendicular to the original. Okay? So for perpendicular, slopes are opposite signs and reciprocals. And b, the y-intercept, can be anything. Okay? So let's start with the parallel lines. So if I'm looking at a line that has y equals 5/7 x plus 3, I'm going to write an equation of a line that also has 5/7 as its slope, 5/7 x plus anything other than 3. Because if I used positive 3 here, then I would have the same exact line, and that's not what I want. So y equals 5/7 x, okay, 5/7 x plus 5. Okay, but you could have had anything there. Y equals 5/7 x plus 5. For the second one, the slope is -5. So the equation of the line I'm going to write parallel to it also needs a slope of -5. And again, I can choose any b value I want other than positive 2, because we don't want it to be the same exact line. We want it to be one parallel to it. So here, maybe I'll choose -4. Okay, apologize, this pen is not the greatest, but we're going to have to play it 4. Third line has y equals -4/3 x minus 7. So any line parallel to it will also have -4/3 as its slope, -4/3. And my b value just can't be -7, so it's a different line. So I'll say +1. You could have had anything there other than -7. And then lastly, y equals 2x plus 3. Any line parallel to it will also have a slope of 2. So y equals 2x, and my b value just can't be +3 because I want a different line, so plus 21, whatever you want. Okay? So all the parallel lines have the same slopes. Okay? Perpendicular. Here's where to write a line perpendicular to one that has a slope of +5/7, I'm going to need to change the sign. So it'll be y equals negative, since this one is positive. I want the reciprocal of 5/7, which will be 7/5 x. And b can be anything. In fact, b could even be +3 because this line has a different steepness. So they're already not the same equation. So I'm going to let this one intersect the other one right at 0,3, the y-intercept. Okay. This one has a slope of -5, which is the same as -5/1. So I am going to need a positive slope, since that one's negative. The reciprocal of 5 will be 1/5 x plus whatever. I'll say 7. Okay. So positive 1/5 x plus 7. 2 more. This one has a slope that is negative, so I'm going to use a positive slope. The reciprocal of 4/3, 3/4. I'm going to say +2. Okay, but b could be anything, including -7 for that perpendicular line. And then finally, I have y equals 2x plus 3. I'm going to need a negative slope since this one is positive. 2 is the same thing as 2 over 1. So the reciprocal would be 1/2 x, and, you know, your choice. I'll go with -5. Okay, -1/2 x minus 5. All right, so that's what we were working on with parallel and perpendicular lines. I am happy to provide any before or after school help on this. If anyone wants to try to retake this particular little exit slip quiz, I'm happy to give you that opportunity as well. I can make these up all day long. All right, and let me know if you have any questions. Okay, our next topic for today is going to be in the linear equations functions pack we've been working in. So you're going to the second page and you're looking for number 17. Here we're starting to work on sketching lines. Okay, and I'm switching pens because I really didn't love that other one. All right, so the first example we're going to look at, number 17, is y equals 4/5 x plus 2. Okay, we know that slope-intercept form. So we can see that our slope is 4/5. We know that's rise over run. And we can see our b value, the y-intercept, is equal to 2. Okay, so in order for it to be the point where the line intersects the y-axis, that would be at 0, 2. All right, so we're going to go find that point. 0, we start at the origin. 1, 2, there's 0, 2, our y-intercept, the b value. Okay. Then we're going to use our rise. Well, it says go up 4. And our run, go over 2. Go over 5. So that's 2, 3, 4, 5. And there's another point on our graph. It looks like that point is at 5, 6. Okay, so I can see the slope here, 6 minus 2 gives me 4. The difference in my x values, 5 minus 0, gives me 5. 2 points is all I need to graph a line. So I can simply draw a line through these 2 points and put the arrows on the end to show that it's a line. And that would be one way I could graph that line. Okay. Given they gave it to us in slope-intercept form, that's probably the easiest way. But remember that if I have an equation of a line, any combination of x and y that makes the equation true is a point on my line. So for example, let's say I took the same equation we're working with and I decided I'm going to use an x value of 5. Okay? So I'm going to actually put that in for x. Y equals 4/5 5, right? Side by side means multiplication, plus 2. Well, we know how to multiply fractions. Y equals 4 times 5 is 20. 5 times 1 is 5 plus 2. Y equals, well, 20 divided by 5 is just 4 plus 2. Y equals 6. Right? So when x is 5, y is 6. That's a point on my graph, 5, 6. And that's the point we already had when we used our rise and run. Okay, so you can go about it trying to work it through in that way as well. All right. So you're going to be asked to look at a couple of slope-intercept ones. You can go back and look at this video and review the approach. Again, what we did above this approach here, right? We plotted B and then used the slope. Okay. Here we were just looking to see if we could come up with a pair of points that worked in the graph, and we just happened to pick x equals 5 because I knew that that would make for a nice result. All right. Let's look at another example. Let's go to the next page, and let's look at a different sort of example. Okay, we'll look at number 23. Okay, so number 23, we have a different set of information here. We have the y-intercept, which we know is where the line intersects the y-axis. Okay, so that's -2. In order for it to be on the y-axis, x has to be 0, and we're going to use that y-intercept value. That's a point on our line. 0, right, at the origin. We don't go left or right because x is 0, and we go up 2. Okay. The x-intercept, you might guess, is where the line intersects the x-axis. Okay. For it to be on the x-axis, y is going to have to be 0. So this one would be -2, 0. Okay. I start at the origin, I go -2, so that I'm still on the x-axis. Right? We know the x-axis is this one, the y is our vertical. Okay. -2, 0, that's a second point on the line. So when we have the x-intercept, right, we can use that information to find the point on the x-axis. When we have the y-intercept, oh, I made a mistake. That is -2, so let's fix that. I went up, and I'm sure you guys were all yelling, no, Mrs. Guest, no, don't do it. All right, I needed to go down, okay? Y-intercept is at -2. Okay. So now I'm going to create my line, because all I need is 2 points to create a unique line, and there it is. So that's an example where you might be using x-intercept and y-intercept, and we'll give you at least another one of those to practice with. Okay, again, feel free to pause at any time if you need to or go back. All right, next example. Here they've given it to us in what's called standard form. This is a different way of showing a line. Instead of y equals mx plus b, you'll remember from last year, you talked about standard form, something like this. Okay? But this is a nice opportunity to use a different method. All right? If I have 3x plus 4y equals 12, all I need is 2 points, and I can graph this line. So let's take 3x plus 4y equals -12. I might not have said negative. And let's see what happens if we let x equal 0. If we choose an x value of 0, we're looking for a y value that would make this true. So if x is 0, I'm going to put that in for x. I get 3 times 0 plus 4 times y equals -12. Okay. Well, 3 times 0 is just 0, so I get 4y equals -12. And when I divide by 4, I get y equals -3. So when x is 0, y is -3. That's a point on my line. In fact, that is the y-intercept. Right? So if I go to 0, -3, there's the point where this line intersects the y-axis. Okay? Now let's do it the other way. Let's see if we can find another point, but this time let's let y equal 0. Okay? So I'm working from the same equation. This time, I'm looking for an x value when y is 0. So I'm going to put in 0 for y. Still is equal to -12. Okay. So I get 3x plus, well, 4 times 0 is just 0, so that's nothing, equals -12. I'm going to solve for x, and I get x is equal to -4. Okay. So in this case, when y is 0, we know y is the second value in our coordinate, x is -4. That's another point I can plot. 1, 2, 3, 4, -4 on the x-axis. I don't go up or down because y is 0. That's my x-intercept. Okay. This is called the intercepts method. Okay. So there we are. I've got 2 points.
and I can